F distribution. Term F is nothing but a random variable, and it is a transformed random variable which represent two variances of two samples taken from two different sources. Basically, the need of F distribution arises when we have to compare two samples taken out from two different populations, and then we have to compare. Certain questions are there whether both the samples have same source properties, where both the samples are taken from two different sources having the same quality or same properties, or whether both the samples have same variances. Now, in the requirement of comparison of variances of two samples, F distribution is used. F is termed as a new random variable, just like Z, T, chi square. So F is a new term over here, which we will see. So in this case of applying the F distribution, generally we have to compare source with the sample. If source is 1, it will have one particular sigma square values, and we are taking two samples, S1 square and S2 square, with respect to N1 and N2. Now we have to compare whether these two samples are having same variability or different variability. There are two types of comparison. One is comparing means of two samples, or comparing variance of two samples. If we have to compare means of two samples, we are taking the use of T distribution. If we are comparing variance of two samples, we will take the use of F distribution. So these are the differences. Here we are considering F distribution. So certain questions we can answer using the F distribution, whether both the samples belongs to the same source, or both the samples are taken out from the sources which have the similar properties. These kind of questions we can answer with the help of F distribution. Now, this F distribution is a variable based on the variable. Distribution is nothing but probability of with respect to F versus F, because F is a transformed variable. So probability versus F. F is a function of nu1, nu2, chi1 square and chi2 square, or rather we can say S1 square and S2 square. Here sequence is important. Whether you are comparing first sample with the second one, or comparing second sample with respect to first one. Sequence is important, and the sample which is being compared is numerator with respect to the other one, which is denominators. So this is the very important in this case, because otherwise the ratio will be reversed and the value will be inverse in comparison to the first comparison. So the sequence is very important. So F is nothing but chi1 square upon chi2 square divided by nu1 upon nu2. Here chi square, we know that it is nothing but n minus 1 s square upon sigma square. So this may be turned into s1 square sigma 2 square upon s2 square sigma 1 square for a sequence of nu1 comma nu2. Nu1 is the degrees of freedom for sample 1, and nu2 is the degrees of freedom for sample 2 of size n2. So this is what is the F variable. Now when we see the real function of F distribution, this is something like this, which is complex function, but we take the help of statistical tables, take the help from statistical tables of F distribution. So these tables are available with respect to certain parameters. Like chi-square table had some variables, relationship between nu chi-square and alpha. Here it is the relationship between alpha, nu1, nu2 and f. So it is a relationship of basically 4 variables, which is reflected either in the form of formula or in the form of tables. So either formula or the table which will define the f distribution, which has a probable shape, something like chi-square distribution. This is f, this is f, and this is the probability with respect to f for a particular combination of nu1 comma nu2. Now this is a typical form of f distribution. If suppose this is probability and degrees of freedom, so if it is a probability, then area under the curve must be equal to 1.0. But if you have to find out the probability at a particular place, for suppose nu1 and nu2 6 comma 10, this is a graph. For 10 comma 30, the another is a graph. So shape changes with respect to change in shape changes with the change in nu1 and nu2. So this is a combination between a particular value of nu1, nu2, alpha and f. This is how we pick up a particular value. So for this area, that is what we call alpha, is nothing but the probability of f when f is more than this value, and this f is nothing but s1 square upon s2 square, assuming sigma 1 square is equal to sigma 2 square and equal to sigma square. So for that case, this is the f. So for this f, this area under the curve is alpha, and alpha is nothing but the probability. But in this case, nu1 and nu2 are important. Which sample you are comparing with the other one? So the sample which is being compared with the other one will have a degrees of freedom nu1, that is nothing but n1 minus 1, and this is n2 minus 1. If you reverse the sequence, definitely this will be reverse. This f will be s2 square upon s1 square. So in this case, this value will go somewhere here, because values will be very less in that case. So in this, the situation will be different, and you will have another distribution with nu2 comma nu1. Suppose this was 3 and 4, so it will be 4 and 3. So that is what the relationship of alpha f nu1 nu2 is reflected either by formula or tables of f distribution. I will show you the tables and then we will solve the problem. You can compare it in a better way. So typical relationship exists in this case. As I told you, if this is s1 square upon s2 square, so that will be nothing but s2 square upon s1 square. So value will be inverse in this case. So this is suppose a relationship which gives a relationship of this one, but in this case it will be 1 minus alpha. The reverse, if this is alpha, this will be 1 minus alpha, and if this is alpha, this will be 1 minus alpha. So that relationship exists in f distribution. If suppose alpha is such a value which is not given in the table, so we will calculate for 1 minus alpha from the table and calculate the inverse one, and that would be the solution for the problem. This relationship is very important in case of solving the problem based on f distribution, because most of the time we cannot have tables with the combination of so many factors like alpha, different levels of alpha, different levels of nu1, nu2 and f. It is very difficult to have a table in few pages for all these combinations. So certain tables are given. With respect to that, we can generate the values, or we are using the softwares, p-value calculators, which are available in market or on the web. So this is what the relationship is repeating over here. S1 and S2 square are the variance of independent samples having n1 n2 as size and sigma 1 sigma 2 square as source variances. This is the relationship. If sigma 1 square is equal to sigma 2 square, the relationship will remain as S1 square upon S2 square. So F distribution is important for comparing two samples. When you are comparing two costly items, the variability is very important, and to compare the variability, you have to take both the samples from two production lines and you will find out the variance of both the samples. And when you compare both the samples variance with respect to F random variable, you take up in the F distribution and you find out the level of significance, and then you take a decision whether both have the similar source properties of in terms of variance or different properties. That is the basic requirement where we apply F distribution. Otherwise we could have applied T distribution for comparing the means. Look at this problem. This problem is comparing two semiconductor devices. 10 soldered leads for semiconductor devices. 10 soldered leads were measured for their pull strength. Maybe pull strength in kgf or newtons, we are not very much concerned about it, but these are 10 soldered leads having pull strength. Another set has 8 leads which were encapsulated to determine whether the pull strength has been increased by encapsulation of the device or not. So they are comparing what the existing production was, and when the production was changed, then whether the pull strength has increased or not. Now comment on the evidence of concerning the equality of two population variances. Although it is very much visible that x bar of sample 1 is less than x bar of sample 2. Very much visible. Although if you have to compare means, then you will apply T distribution and you will see the difference of x1 bar and x2 bar, which is very clear in this case that pull strength has increased. But they want your comment about comparing the two population variances. Then you have no option than applying F distribution. When you apply F distribution, you calculate the value of F, which is S1 square upon S2 square, assuming that sigma 1 square is equal to sigma 2 square. If we compare this, then we can go for comparing these two samples. For that case, take up the problem. If suppose we take this data into Excel and we calculate the sample variances of both set of values, and then we will perform the test whether both have changed or not, both have increased or not, to see that if I calculate the variance of this variance of sample, and this is a sample here, calculate the variance of the sample. Here also I will calculate the variance of the sample. This S is for the sample, so this is here. We know these are 8 values, and these are, if you have to calculate mean, you can calculate mean, although these are the values of the variance. So S1 square is 10.44 and S2 square is 1.84. N1 is 10, N2 is 8, nu2 is 8 minus 1 7, nu2 is 10 minus 1 is 9. Now here what you see, S1 square is 10.44, S2 square is 1.84. Now if we have to calculate the F value, if suppose we have to compare variance of S1 square with respect to S2 square. So now in this case, F will be S1 square upon S2 square. This is what I call F calculated, assuming sigma 1 square is equal to sigma 2 square. So in this case, what will be the value of F? 10.44 divided by 1.84, that's become this divided by this, 5.66. Now if we have to draw the F distribution for a particular value of nu1 as 9 and nu2 as 7, this is a combination. So F comes somewhere here. For example, this is F calculated equal to 5.66. So what is the value of alpha? We have to see what is this. But for this, we will, alpha is obtained from tables of F distribution. Now here we will see the role of F distribution table and how we can use them. In this table, this is a relationship which is given. In this relationship, this is F alpha. F alpha and respective alpha value is given, but for nu1 comma nu2. First row is nu1. This is nu1 row. First column is nu2. So our nu1 is 9 and nu2 is 7. So according to 9 and 7, so 9 is this and 7 is this. So value is 3.68. For 3.68, the value of alpha is 0.05. Now see in another table, alpha was 0.05 for F 3.68. Now here for nu1 9 and nu2 7. 6.72 F values. Alpha is 0.01 for F, 6.72 for the combination of nu1 as 9 and nu2 as 7. We have that format of the table in such a way that whole table which is visible over here is for one particular value of alpha. The other table was for the one particular value of alpha 0.05. This is for 0.01. So we have very limited tables for 0.05, 0.01, 0.1, not for many other F values. So if we have for these values, if suppose you have to find out for 0.99, you will go for the inverse relationship. So here, if I 72. But our value, calculated value is 5.66. So it will be somewhere here. So it means that the value of alpha is more than 0.01 but less than 0.05. It will be somewhere here. That is what the conclusion we could draw from here. But if we take the help of online p-value calculators, let's go on the website. So I will write here p-value calculator for F. So if we open this, I put the value of F 5.66 and degrees of freedom for numerator is 9, for denominator is 7. And if I calculate this, the value of F is, value of alpha is 0.0162. So that is less than 0.05. In this calculator, what we see over here is, this is the value 0.01625. So exact value of alpha we get 0.0162, which is somewhere here. So it is if we say it is more than this particular value which is at f.05 and less than the value at f.01. So at f.01 the value was 6.72 and for 0.05 the value was 3.62 and the f calculated is 5.63.
Sometimes there is a rule that if one sample variance is not equal to the other sample variance, which means that the source variances of both the samples are not equal. That is only possible when the value of P is less than 0.05. 0.05 is a thumb rule.
But in our case, this value goes less than 0.05. So it means we say that there is a significant change in the variance of second sample. So this value comes as 0.0162, which is less than 0.05. So it means the ratio S1 square upon S2 square is going beyond the acceptable region. This is acceptance zone. So it is going beyond the acceptable region in the critical region. It means that S2 square is significantly reduced compared to S1 square. It means the variance of sample 2 is reduced compared to variance of sample 1. So this encapsulation techniques reduces the variability as well as increases the mean strength. That is what we can conclude from using F distribution. Let's take another example here of two samples, one having a sample size n1 as 8 and another as n2 as 12. One has a variance S1 square, other S2 square. Assuming the source same variance, they want to know what is the probability that S1 square upon S2 square will be less than 4.89. To know this, we have to take the help of F distribution. So here I can write again n1 as 8 and 2 as 12, looking for the probability S1 square upon S2 square less than 4.89. This is what I have to see. So if I draw F distribution, so in case of F distribution, this value of F will be somewhere here. For example, F is 4.89. So we are looking for this probability. We are not looking the probability more than this particular value. So we are looking for the probability when F is less than 4.89. So as per the table of F distribution, values are given for alpha 1 minus P F more than 4.89. So if we can pick up this value from the table for a particular value of nu1 as 7 and nu2 as 11. So for this combination, if we see the tables of F distribution, then we can find out this term as 1 minus this thing we have to see there for alpha 0.01, nu1 is 7, nu2 is 11. So the value is 4.89 for a particular. Fortunately, we are in the first table, we are looking for the value. This is 4.89. So for 4.89, the value of alpha is nothing but 0.01. So it means that over the distribution, if this is a 4.89 F, then this area under the curve is 0.01. Then in that case, this is nothing but 0.01. So this value is 0.99. So probability, this way we can pick up from the table of F distribution. Take some more examples. These are just the pickup of the value and the use of the inverse relationship. For example, here alpha is 0.05 nu is 7, nu2 is 15. From the table, we can directly pick up the value of nu1 7 and nu2 15, 0.05. So nu is 1 is 7, nu2 is 15, the value is 2.71 for alpha 0.05. This value is f equal to 2.71. For second, again the same thing. So 1 is 15. So 1 is 15 and the second is 7. So the value is 3.51. 2.71, second 3.51. For the third case, you can see the other table. Now see these two problems over here. These are different. For f 0.95, nu1 19 and nu2 24, but we don't have a table for this alpha. So this value will be nothing but equal to 1 upon f 0.05 24, 19. So this value we will see from the table. For f.05, nu1 is 24, this is here, nu2 is 19, so the value is 2.11. So this is nothing but 1 upon 2.11. That will be the answer for the first part of it. For second part, it is nothing but equal to 1 upon f 0.01 12, 28. So that way we can go to the other table and we can pick up this value, and reverse will be the answer for the problem. So in this case of F distribution, we have picked up one problem which was used to compare two samples based on the variances of both the sample, whether the variability of the product has been improved or deproved, like this. Second, we have taken the problem where we have tried to explain how to use the F distribution table. In the middle of the discussion, we have also shown you that if you don't want to use the tables, you want to directly pick up the value from the internet, you can go there and pick up the value of alpha. That would be helpful. And this is not only available for F distribution, it is available for chi-square distribution, it is available for T distribution, it is available for Z distribution. If you know the other parameters, you can calculate the value of alpha. I hope it may help you in solving or in making the decision based on statistical inferences. Thank you very much.